Thanks for the invitation. Panasys pioneered the first parallel file system about 20 years ago with general availability in 2003. We've applied our 20 years of experience serving the HPC industry with our latest product, the ActiveStor Ultra. With over 500 deployments in 50 countries, in key industries, we serve both the traditional and emerging HPC applications. The latest Panasys product, the ActiveStor Ultra, is the first portable Panasys file system running on COTS hardware. What you get with a Panasys parallel file system is all of the technology we've learned over the last 20 years. The new Panasys PanFS 8 parallel file system software has been rewritten from the ground up. We actually had started with a FreeBSD based. We've actually moved over to a Linux. Now we can actually use the current drivers, the current technology of NICs, etc. This took a year and a half of Panasys experience to do. It's, again, built on the Linux OS and is completely portable. When we say portable, we actually mean that it needs to be properly configured. We're not providing an ISO you can download and put it on any hardware. One of the key attributes of Panasys software is being able to manage it easily, administer it, have the users be able to transparently use it on a cluster. Those type of environments require some integration even with COTS hardware. So we can't just provide on any piece of hardware. The direct flow client is our high performance parallel I/O driver, which runs on all major distributions of Linux. Some of the key attributes that we have with all Panasys products are that they're fast. With the ActiveStor Ultra, each building block is a 4 GB per second addition. We actually can build these on up with no real limitations that we've found as yet. That's simple. This is probably one of the key attributes of Panasys, is that all Panasys products were designed from the get-go as an appliance-based architecture. We always want to maintain that architecture so it's easy to use, both from an administrative standpoint, from a standing up standpoint, and from the end user, the scientist. And then it's flexible. Being able to combine different drive types, different striping layouts from a standpoint of a user can be quite advantageous for the applications developer saying, I want a wide stripe, or I want a narrow stripe, whichever it is that meets those requirements. But the nice thing is in a single namespace. Very key for administration, especially for large data centers. And it's reliable. With our distributed object RAID system, actually as you increase the size of the environment, reliability goes up, not down. We have a distributed object RAID architecture, which allows the data to be spread more. And finally, cost effective. We use the terminology TCOO, which is total cost of ownership and operation. In a recent survey we had with Hyperion, they found that with BGFS, with Luster, and Spectrum Scale, that a 5-year distributed cost of administration could be $1.5 million. With Panasys, we actually have government customers who tell us that in a case of a 14 petabyte environment, they're using 15% of a 1 FTE. So that's a savings of over $1 million.
Okay, well, very good.
All right, so thanks, Dale.
Questions, thanks, Dale.
Your first question, this is right from your first slide. What defines a parallel file system as portable and plug and play in the sense of having the first portable plug and play parallel file system?
Right, so portable, as I mentioned, it's, our original design was using, this is starting in 1999, there wasn't a lot of storage hardware that was available off the shelf. Mm-hmm. So we actually had to build our own product. We had to build our own blades, our own network infrastructure. So what we actually were able to do is actually move to select a platform, in this case the first one was Supermicro, that actually has all the characteristics of being able to support concepts of parallel file system technology. So what we call portable is that we can run PanFS 8 on any comparably configured storage
Stay
hardware.
with the mic. I'm sorry I interrupted you. I just didn't want you too far from the mic so the audience can hear. Go ahead.
So again, the PANFS 8 can run on any comparably, appropriately configured hardware package. That means it's not just a NIC and memory and CPU, but it's also things like NVDIMM to protect from power failure, those type of things.
All right, thank you.
Okay, this is a secret question for you, Dale. Is your implication that Panasys' multi-petabyte storage system will be more reliable than a 100-terabyte system? Because it says reliable, automated data reliability increases with scale.
Absolutely, yes it is. So, and the idea is that since we have a distributed object RAID, we have more targets. Each of our storage nodes actually is an intelligent device. So if we take your file, we can spread it across 10 of 100 or 10 of 1,000 blades. The chances of a failure impacting 2 down or 3 down of your file actually gets lower as the scale
But that's
goes
just
up.
through redundancy, basically, right? Or replication.
I'm sorry?
That is just through redundancy or replication or something, is it not?
No, it's actually distributed.
Okay.
All right, next question. Within Panasys' HPC storage system, what specific thing adapts and how? Seamlessly adapts to changing workload. What adapts?
Okay, there's a couple things that the system adapts or has adaptations to. Probably the most common one that every Panasys customer sees is something called automated capacity balancing. In the case where we have these storage nodes, certain usage patterns can actually cause the capacity to increase on a particular node or two. So with increased capacity, you have the characteristic that it may become hotter because there's more data out there being used. If it's hotter, it could be slower. With a parallel file system, as you know, it's only as fast as the slowest component, not the fastest component. So what we want to do is actually spread that data around to where the use is actually even. Therefore, the parallel I/O actually completes all at the same time frame.
Well, so now that machine learning and AI are the buzzwords, are you saying that this is like an AI system?
I wouldn't say AI, but there are certain things that we've learned over time, which is what AI is. So, certainly ours took 20 years, whereas AI might be able to do it in 2 minutes.
Okay. Okay, your last question. This is also a secret question. In one of your slides, it says, eliminates I/O bottlenecks with limitless performance. This is really, it seems like a challenge to us. What is the practical?
It's not magic. So it eliminates the I/O bottlenecks. So each of our storage, a traditional storage platform is disk behind some RAID controller or behind some head. And you can adjust the parameters of each. You can put more storage for capacity, but that's not how you really scale out. With Panasys, each node, each 4U building block actually provides capacity, CPU, NIC, network performance. So as you increase the number of building blocks, you're actually creating more and more I/O potential, as well as capacity.
I see. Okay, well, very good.
All right,
Thanks, Dale.
Very much.
Thank you.